So we're going to look at the product rule day 2. So with our product rule, remember it's all about multiplication and the changing of exponent powers. So yesterday we looked at examples like this. So according to the product rule says that when I have two things with the same base, for instance, in this problem, the x's, and those bases are being multiplied, I am allowed to add the exponent powers. This x has a 1, so 1 plus 2. Our final answer for this one would end up having an x to the third power. If we look at the coefficients, the numbers that are in front of our variables, they would multiply as well. This is a 1. 1 times 3 gives us 3. Turn our attention to the y's. Y to the fourth times y to the second becomes this, so we can add the exponent powers, 4 plus 2, and we get y to the 6th. And this would be the last thing that we can do, because none of them are the same base. We can't actually multiply any of them, so they stay as this simplified expression. So what we're going to introduce today are negative exponents. So positive exponents mean multiplication. Negative exponents actually mean repeated division. Biggest thing about negative exponents, if I have 3 to the negative 4th power, I would have 4 of these, but I'm actually going to flip them. Ooh, excuse me. And it would become positive on the bottom of a fraction. So negative exponents actually cause the base to flip to be on the opposite side of the fraction. This one was on the top, it's now on the bottom. If it was already on the bottom, it would become positive on the top. It basically switches places. So n to the negative 2nd power becomes 1 over n squared. The 1 is only there because of the need to have something on the top of our fraction. The n to the negative 2nd power moves to the bottom of the fraction. We can't just leave the numerator empty. We can't put 0 because that would mean nothing is here. That's not true. So we put a 1 for a placeholder. If I have this, 4k to the 4th, only the k has a negative exponent, not just the 4. So in this problem, the 4 stays on the top. It doesn't have a negative exponent. It doesn't move. The k does. And now it's on the bottom. Same goes with this one. 2 doesn't have the negative exponent. It stays on the top. The x moves to the bottom. Whoops. But when it moves, it becomes positive because it's in the opposite spot. Even if we have other variables, only the x is negative. So everybody that doesn't have a negative exponent stays on the top. One big thing, x to the negative 2nd power in no way becomes this. It does not become a negative x squared. The negative is up in the power, so it controls something different in the problem. So for instance, if you have 4 to the negative 2nd power, the answer is not negative 16. No. 4 to the negative second power becomes 1 over 4 squared. So the answer is 1/16. Has to be repeated division. Negative 16 is not repeated division. It still got larger multiplication there. 1/16. So if we look at the product rule with negatives, nothing changes about the process other than just having some of these negative numbers. So the regular numbers multiply. 3 times 2 gives us 6. We then turn our attention to the x's. X to the negative second times x to the negative fourth, or next to the fourth. Because they have the same base, they're both x's, they're multiplying. We're going to add the exponent powers together. That means negative 2 plus 4, and in this case it becomes x squared. 4 minus 2. And we're done. Maybe they're both negative like this. Once again, we're going to multiply our regular numbers. 2 times 3 is 6. We then have x negative 2 times x to the negative 3. Both the same base, so we add the powers. And we get x to the negative fifth. We cannot have any negative exponents at all. So we have to simplify this. The 6 does not have a negative exponent, stays on the top of the fraction. The x does have a negative exponent. We have to move it to the bottom of the fraction. And our final answer would be this. If we have more than 2 terms, it's still the same kind of idea. We're going to first multiply all the regular numbers, our coefficients. 3 times 3 is 9 times 2, so we get 18. Then we get negative 1 plus 4 plus the 1 that's on this v over here, even though it's not listed. That gives us 3. 3 plus 1 gives us 4. V to the 4th power. Nobody is negative. No one has a negative exponent, I should say. So it stays just like that. So let's finish with this one, because it looks super duper crazy, but it's all about moving one step at a time. So first thing, I'm going to multiply all of my coefficients, including the one that is not currently listed here. 2 times 1 times 2 gives us 4. Now I'm going to move my attention to the x's. So there are no x's in this last one over here. Negative 3, positive 3. Well, that cancels each other out. There are no x's left. Move on to the y's. For the y's, I have 4 plus negative 2 plus the 1 I have down here. So that gives us 2 plus 1. So we get y to the third. Then the last thing are the z's. Z to the fourth, z squared. So we have 4 plus 2 minus 2. Basically, these two cancel each other out and give us z to the 4. So it seems like this is a lot going on, but all we have to do is worry about one term at a time. I don't want to use the word term because technically this whole thing is one long term. One letter at a time. So we deal with the numbers, we dealt with the x's, we dealt with the y's, then we dealt with the z's. We're left with this statement. None of them are the same base. We can't solve this because it's not an equal. There's no equal sign. Nothing we can do. We end our problem right here. This is it simplified.